All right, now we're going to do, because remember, we're going to be faced with large polynomials. It can have any degree at all. And we're going to be able to take that and find the x-intercepts, the solutions that'll help us graph our function. Consider what we just did. We took an equation, f of x equals x cubed plus 2x squared minus 5x minus 6. What we're going to be using the next couple of sections, we're going to find the solutions. We're going to find the factors. We know it's a degree 3 polynomial, so we have 3 solutions. So when we factor this one, if it's factorable, we're going to get x plus 3, x plus 1, and x minus 2. Which means that our real zeros are x equals -3, -1, and +2. And I'm going to show you in a second how we could use polynomial division to determine if these are factors of that. Let's try something small first. X squared plus 5x plus 6. Is x plus 2 a factor? Is this, well, actually, I would have said, is x plus 2 a factor of x squared plus 5x plus 6? That's the question that would have been posed. To determine if it's a factor, determine if it is a factor, we use polynomial division. In polynomial division, we have 2 types. We have long division, and then we have something called synthetic division. The difference of those two, long division is a division we're used to. Synthetic division is a division process that only uses the coefficients, the numbers. There are no letters in it. So let's look at this. Long division. If we take the denominator and divide it into the numerator, so for example, if we had 15 divided by 5, we put that. What would we put on top here? Yeah, how many times is 5 going 15? 3 times. Then what do we do? 3 times 5 is 15. Change the sign and add. This is the remainder. If the remainder equals 0, then the denominator is a factor of the numerator. So that's what the whole first part's about. If when we do the division, long division, if the remainder is 0, then we know that 5 is a factor of 15. Well, let's see what that means. What that means is that 15 is equal to 5 times 3. That's one of the factors of 15. It tells us also that 5 is a real 0 for or of 15. All right, let's look at this. So in our example, once we have these polynomials and everything, we only look at the first terms. What times x gives me x squared?
Oh, it's X.
X.
Not like
Yeah, you can't just put a 2 there. So then we do the same thing we did here. We go x times x is x squared. X times positive 2 is positive 2x. Change the signs and add. The first term has to cancel out. If it doesn't, you did something wrong. So 5 minus 2 is 3x plus 6. Repeat the process. Look at the first terms. What times x gives me 3x? A positive 3. Then positive 3 times x is 3x. Positive 3 times positive 2 is a positive 6. Change the signs and add. So our remainder is 0. So what does that tell us? Right. So we know that x squared plus 5x plus 6 is going to equal x plus 2 times what we just found, the x plus 3. So those are the factors. So long division checks to see if that's a factor, and it tells us what the next possible factor is. So we just found the factors of x squared plus 5x plus 6. Make sense? So let's look at an example here. Determine if x plus 1 and x minus 3 are factors of x cubed plus 2x squared minus 5x minus 6. So let's do the first one. We have x plus 1. And then we have the x minus 3. We have to do them both. So what times x gives me x cubed? X squared. So x squared times x is x cubed. X squared times positive 1 is positive x squared. Change the signs and add. 2x squared minus 1x squared is 1x squared. Bring down everything else. And repeat the process. What times x gives me x squared? A positive x. Yeah, yes, the sign's important because if you just put x up there, we don't know what connects them. There has to be so it's a positive x times x. Because this could be a negative also.
Okay.
So positive x times x is x squared. Positive x times positive 1 is a positive 1x. Change the signs and add. The x squareds cancel. Negative 5x minus 1 is negative 6x. Bring down the 6. So what times x gives me negative 6x? Now it's a negative 6. So negative 6 times x is negative 6x. Negative 6 times 1 is negative 6. Change the signs and add. A remainder is 0. Yes, it is. So we know that x cubed plus 2x squared minus 5x minus 6. The factors of those are it's x plus 1, and then whatever's on top. X squared plus x minus 6. So now, how many answers are we supposed to have? Nope, we're supposed to have 3 of them because the degree is 3. Yeah, so we got these 2 so far. Now, if we wanted to, we could even take this one step further. So opposite signs. Yeah, 3 and 2. Because 2 times 3 is 6. 3 minus 2 is 1. So these are our factors. So the real zeros are negative 1, negative 3, and positive 2. Those are my x-intercepts. That's how it's going to work. Now let's do the other side. What times x gives me x cubed? That's going to be, we know it's not going to work because we figured out what the factors are. We know this is not going to work. So, but let's just go through it. X squared times x is x cubed minus 3x squared. Change the signs and add. Bring down the other stuff. So what times x gives me 5x squared? A positive 5x, right? So positive 5x times x is positive 5x squared. Positive 5x times negative 3 is negative 15x. Change the signs. 15 minus 5 is 10x minus 6. And the last one, what times x gives me 10x? Positive 10. 10 times x is 10x. 10 times -3 is -30. Change the signs. The remainder is 24. So, no. It's not a factor. So that's how it works. But here's something even more cool. I know I'm probably jumping out of off script here, but this is what I think is really cool. Like in the first one. In the first example, we had x squared plus x minus 6 divided by x plus 1. If we took the denominator and solved it, what are we going to get? -1. If we took this -1 and put it inside here, oh, no, I'm sorry, wrong one. The original equation. It was x cubed plus 2x squared minus 5x minus 6. I'm sorry. So we have to look at the original equation. So if we took the original equation and divided by x plus 1. Okay, we saw that we can use long division. But if we take the bottom and solve it and plug this answer into the top, so it's -1 cubed plus 2 -1 squared minus 5 times -1 minus 6. -1 cubed is -1. -1 squared is 1. -5, -1 is a +5 minus 6. So we have -1 plus 2 plus 5 minus 6. So we have -1 and -6 makes it -7. +2, +5 makes it +7 equals 0. So the same thing's going to work to see if this is a factor. Is x minus 3 a factor? Well, set it equal to 0, solve, and plug it back inside there. So 3 cubed is 27. 3 squared is 9. 5 times 3 is 15. We have 27. 2 times 9 is 18. 15 and 16 is -21. So 27 plus 18 is 45. 45 minus 21 is? That was the remainder that we got. So if you're asked to check, is this a factor of that or not? Just take the bottom number, set it equal to 0, and plug the number in there. If it's a 0, it is. If it's not, it's not.
If you basically eliminate it for the long division.
Well, it makes it faster. You need the long division because here, even though it's 0, it doesn't tell us what the remainder is, what the other equation is. We knew that here, once it equals 0, I have to work with this now. I'm done with this big one. I know that's a factor. I have to work with this now. But this method here, it just tells me, if it does it as a factor, then I do the long division and it'll give me an answer. But let me see if it's introducing. So yeah, that's what it's saying is if your remainder is 0. Now, a faster method. Synthetic division. Only works if the denominator is of the form x plus or minus some number. It's got to be a linear equation. X cannot have any powers. It can't be negative. Can't have a coefficient. So if that's the case, synthetic division is this way. Let's look at what we just had. Let's look at x cubed plus 2x squared minus 5x minus 6. Remember, what this says is x plus 1 a factor of the numerator? That's how we'd set it up. So if I'm asking you if it's a factor, then I do division. Synthetic division doesn't work with letters, only works with numbers. So here are the steps. Set the denominator equal to 0 and solve. So here's my step 1. I took x plus 1, set it equals 0, x equals -1. 2, take that value. This is what indicates if it's synthetic division. Upside down division. Set up the synthetic division. Where this number here goes at this place here. Now, inside here, only the coefficients of the numerator. And you have to make sure that you allocate each column. So we have x cubed, x squared, x, and a constant. Since the first term is an x cubed, I start off with that. And then I count down everything after that. So what's the coefficient of x cubed? 1. What's the coefficient of x squared? X, -5, and -6. bring down the first term. So bring down the first term. Then you multiply this number by this one, putting it there. Then you add straight down. 2 minus 1 is 1. Repeat the process. Negative 1 times 1 is negative 1. Add straight down. Negative 5, negative 1 is negative 6. Repeat the process. Negative 1 times negative 6 is 6. Add straight down. This is your remainder. If the remainder is 0, then the denominator is a factor. So in this case, x plus 1 is a factor. But here's another thing. Remember when we did long division? We got the last part of the equation. That's what this tells us. If that's 0, these are the coefficients of my remaining polynomial. This is a constant. This is my x term, and this is my x squared. So the remaining polynomial is that. All right, let's do some more of these and get used to doing synthetic division. Once you get used to it, it's gonna save your life so much faster than anything else. Two x cubed plus 7x squared minus 5 divided by x plus 3. It's asking you to find the quotient and the remainder. Dividend, divisor, quotient plus remainder. This is how a fraction problem is always set up. All right, so let's look at synthetic division here. Can we use synthetic division? Because the bottom is x plus or minus a number. So first step, take the bottom number, set it equal to 0. So that goes on the outside. And on the inside here, since the largest power is x cubed, I have to put the coefficients of each of these columns. So what's the coefficient of x cubed? X squared? X? Right, doesn't exist, so it's 0. And then the constant is negative 5. First step, bring down the first term. Negative 3 times 2 is negative 6. Add straight down. 7 minus 6 is 1. Negative 3 times 1 is negative 3. add straight down, I get -3. -3 times -3 is +9. 9 minus 5 is 4. That's my remainder. So my quotient is this. This is my quotient. This is my remainder. So the quotient looks like what? No, because it started off with x cubed. We had x cubed and you divide it by x, you get what? Squared. Then it will be positive x and then -3. That's my quotient. The remainder is 4. The quotient, because whenever you use synthetic division, because the denominator is always x plus or minus a number, the final answer will be one less exponent because it cancels out. Example 3. F of x equals 2x to the 5th minus 3x to the 4th plus x cubed minus 2x squared plus x minus 8. Find f to the 10th, f of 10. We did that. All right. An easy way of doing this one is use synthetic division.
You sort of put that in.
Yep. And whatever the answers are going to be, that's the same as you plugging the numbers in there. So we have 2, -3, 1, -2, 1, -8. Bring down the first term. 10 times 2 is 20 minus 3, 17. 17 times 10 is 170. Plus 1 is 171. 171 times 10 is 1710. Minus 2 is 1708. So far, so good. Times 10, 17080. Plus 1 is 17081. Times 10 is 170810. And minus 8, 170802. And there's your answer. F of 10 is equal to 170802. I've always thought that was really cool. It's much faster doing that than plugging in there 10 to the 5th is this, 10 to the 4th is this. It's a lot of work. So this is much easier. Four. Is 5 a 0 of g of x, where g of x is equal to x to the fourth minus 26x squared plus 25. So we set it up. 5x to the fourth, x cubed, x squared, x and constant. X to the fourth coefficient is 1. There is no x to the third. Negative 26. There is no x and 25. Bring down the 1. 1 times 5 is 5. 5 plus 0 is 5. 5 times 5 is 25. Minus 26 is negative 1. 5 times negative 1 is negative 5. Plus 0 is negative 5. 5 times negative 5 is negative 25. Plus 25 is 0. Yes. 5 is a 0. And the last one, if we have time. This one is very exciting. Is I a 0 of f of x equals, I know this would be pretty cool. So now we got to set it up. Is I a 0? So it's x cubed, x squared, x and a constant. So it's 1, negative 3, 1, negative 3. Bring down the first term. Multiply. I times 1 is I. You add these two, you get negative 3 plus I. Now we multiply. I times negative 3 is negative 3I. I times I is I squared. Well, remember, I squared is negative 1. So take this, add 1 to it, the 1's cancel, so we get negative 3I. So I times negative 3I is negative 3I squared. I squared is negative 1. So it equals 3. Negative 3 plus 3 is 0. Yes, I is a 0.
Now it's gonna be like this.
Well, it'll be ugly like this, yes, but it's not always going to be a 0. No, that's a really good question. No, it won't always be that ugly. No, it won't always be that sweet. Because that was pretty easy for us. All right. The reason I'm saying is